The time is now 1 p.m. and we are still missing quite a few panel members, so we'll wait a few minutes.
Diana, this is Levia. I just want to do a sound check while we're waiting. Can you hear me?
Yes, I can hear you. I can hear you fine.
Thank you.
Good afternoon. I am Dr. Diana Wong, the designated federal officer for the Radionuclide Cancer Risk Coefficient Review Panel meeting. I would like to welcome everyone for participating in today's meeting. Before we start, I would like to take the roll call. Dr. Yiling Shu? Dr. Yiling Shu?
Yes, I'm here.
Thank you.
Good morning.
Good afternoon, according to our time. Dr. Maya Delashvili, she told me that she cannot participate today. So Dr. Roland Banky?
Present.
Thank you. Dr. Harry Coolings?
Yes, I'm here. Hello.
Thank you. Dr. Eric Grant?
Yes, here. Thank you very much.
Thank you. Dr. Mark Little?
Yep, present.
Thank you. Dr. Jinhua Mao?
Yes, I'm here. Thank you.
Thank you. Dr. Bruce Napier?
I'm here.
Thank you. Dr. Ruth Pfeiffer? Oh, she sent me an email that she has a family emergency. Dr. Charles Potter?
I'm here.
Thank you. Dr. Steve Simon?
Present.
Thank you. Dr. Daniel Stram?
I'm here. Hello.
Thank you. Dr. Daniel Strong? Dr. Daniel Strong? Okay, she's not here yet. Dr. Wei-Sheng Wang?
Present.
Thank you. Dr. Gail Woloskin? I think I saw her.
Did you mean Gail Woloshak?
Oh, I say her name wrong, huh? Is she here?
Yeah, well, she was here.
Yeah, I think I saw her before, earlier.
I think
Maybe she's just stepping out. Okay, we get back to her later.
yeah.
Dr. Lydia Zabrowska?
I'm here.
Thank you. So we are just missing one. Maybe she'll join us later.
I can actually see Gail. She's here.
Oh, she's here?
Yeah, she's well, her video's on. Her sound isn't.
Yeah, maybe she mute herself. Can you unmute yourself, Gail? Because I can see you,
She
but I
can't.
cannot hear you.
She can't hear you, obviously.
Well, anyway, we have to move on. I know she's here then. Good afternoon. I'm Dr. Diana Wong, and I am the Designated Federal Officer, or DFO, for the Science Advisory Board, SAB, Radionuclide, Cancer Risk Coefficient Review Panel. In my role as the DFO, I would like to formally open this public meeting of the Radionuclide Cancer Risk Coefficient Review Panel. The purpose of this meeting is for the SAB Radionuclide Cancer Risk Coefficient Panel to listen to the agency's presentations on the draft Federal Guidance Report number 16, that is FGR 16. Listen to public comments and also to discuss the charge questions. The SAB is an independent, expert federal advisory committee chartered under the authority of the Federal Advisory Committee Act, or FACA. The SAB is empowered by law, the Environmental Research, Development, and Demonstration Authorization Act to provide advice to the EPA administrator on scientific and technical underpinnings of the EPA's decision. FACA and EPA policy requires that SAB meetings be announced to the public in the Federal Register, and that substantive deliberations and interactions with EPA and the public be conducted in open sections where DFO is present to ensure that the requirements of FACA are met. FACA also requires that public meetings provide an opportunity for oral and written public comments. There is a public comment period noted on the agenda for this meeting, where members of the public can register in advance to the SAB staff office to make oral comments. We don't have any registered public speakers for today. Minutes will be prepared to summarize discussions and action items in accordance with requirement of FACA. The SAB staff office will work with the panel chair to have the official minutes certified so they can be posted on the SAB website. The SAB consists entirely of special government employees appointed by EPA to their positions. As government employees, all the members are subject to all applicable ethics laws and implementing regulations. The SAB staff office has also reviewed other information related to the public statements expressed by experts on this panel related to the advisory activity under consideration. EPA has determined that advisors participating in this meeting have no financial conflicts of interest or appearance of lack of impartiality under ethics regulation related to the topic of this meeting. Now I would like to turn the meeting over to Ms. Connor Johnston, the Deputy Director of the SAB Staff Office, to give her welcoming remarks.
Thank you, Diana. I wanted to welcome everybody today. Good afternoon. For those of you both on the on the West Coast, good morning. On the East Coast, good afternoon. First and foremost, thank you so much for being willing to serve on the Radionuclide Cancer Risk Coefficient panel. That is a mouthful. So from this point on, I'm just going to call it today's panel. And we are so appreciative of your willingness to provide us with valuable input on the draft federal guidance, which is the update to cancer risk coefficients for environmental exposure to radionuclides. My name, of course, as Diana mentioned, is Kana. I am privileged to be here with you today. I serve as the Deputy Director of the Staff Office, and I am very, very excited to welcome you. This has been a long time coming. As you know, we formed the panel quite a while ago, so thank you all for your patience and being here today. Tom Brennan, the Director of our SAB office, the staff office, extends his apologies. He's sorry he couldn't be here this afternoon, morning on the West Coast. He is covering another panel meeting today, but he'll be coming to join us later this afternoon. And of course, you'll see us in person or on the screen when we have the face-to-face in May. I wanted to especially thank Dr. Zhu, who has graciously agreed to serve as chair. We know that takes extra time and work to bring the group's responses to the charged questions to consensus, and also to bring the document to the final stage for the SAB quality review. Tom and I are very lucky. We are supported by an amazing staff. We have a team of analysts who are responsible for the hiring and logistics for the meeting that you will be attending in May, but also for taking care of your travel arrangements and making sure everyone gets paid. And we have wonderful technical support through our contract. We have very talented contractors that help ensure our meetings. So we couldn't do this without them for the virtual meetings and the hybrid meetings. Finally, you have met Diana. Diana is your DFO, and as the DFO, she will guide you to ensure that we follow the rules of the Federal Advisory Committee Act, which she's already mentioned, and that is how all advisory committees operate in the federal system. So we couldn't do it without her, so thank you very much. Most of all, we sincerely appreciate you making the commitment to serve as special government employees and the time you're going to take to spend on this peer review to provide your advice on what the document is lacking, what is not clear, and how does EPA and the other agencies involved improve the document. Thank you. And with that, I'm going to hand it off to Dr. Zhu to introduce himself today and to please kick off today's meeting. Dr. Zhu.
Thank you so much. Well, it's a privilege for me to serve as a committee chair, and I look forward to working with all the panel members and also the EPA officers and the staff to make this effective and fruitful process. And so my name is Li Liangzhu. I'm professor and a division chief of epidemiology, biostats, and preventive medicine in School of Medicine, University of New Mexico. My training background is in computer science, stats, and also environmental health. So I've done work in risk assessment and data blending of stats and environmental health brought me to in many committees relating to concerning environmental issues. With that, I'm going to turn to, I just have a warning that I'll get warning about unstable or unstable internet access. So if something happens, and I think I'll victimize Diana to take over, but I hope that it'll keep at least at this level. Now I lose the other screen on the panel member. My apology. Okay, so maybe I'll just go by screen right now instead of following the panel membership list. Oh,
Do you want me to call their names?
I can do it right now.
You can see them? Okay, sure. you
Yeah, I
do
can
that.
see from screen. Dr.
Okay.
Wishun Wang, please.
Dr. Wang?
It's me?
Yeah.
Yes.
I'm sorry. Actually, I'm in Taipei right now, so it's 1 o'clock in the morning. So I'm a little bit slow. I'm Wei Shang Wen, and I'm a applied health physicist. Currently, I'm the professor of health physics at Louisiana State University. Thank you.
Harry.
Dr. Collins, I think you've been called. Oh, okay. Hi, I'm Harry Cullings. I'm retired from the Radiation Effects Research Foundation in Hiroshima, Japan, and I'm a biostatistician and radiological physicist.
Thank you. Dr. Simon.
Hi, I'm Steve Simon. I'm
Sorry.
retired from the National Cancer Institute. Oh, that's right. I'm retired from the National Cancer Institute about 2 years ago, where I was for the last 22 years. I'm a radiation physicist by training, and I've been involved in many aspects of dosimetry for epidemiologic studies, development of methods for uncertainty analysis, and that kind of thing. Thank you.
Thank you. If I don't pronounce your name correctly, please correct me. My apologies in advance. Dr. Bank.
Sure. Roland Benke, director at
Okay.
Renaissance Code Development with a background in radiation detection, dosimetry, and risk analysis.
Thank you. Dr. Mao.
Yes. My name is Jianhua Mao. I'm a senior scientist at the Lawrence Berkeley National Lab. My training is really a lot of mixed background. I'm training from mass cancer epidemiology and do the cancer genetics. I've done a lot of work with how to genetically interact with radiation to cause cancer risk.
Thank you. Dr. Mark Little.
I'm the National Cancer Institute at the Radiation Epidemiology branch. I'm a statistician, and I've been there for the last 14 or so years. For that at Imperial College.
Thank you. Dr. Daniel Stram.
Hi, I'm from the University of Southern California, and prior to coming, I worked at the Atomic Bomb Survivor Study, and I've stayed in contact with radiation epidemiology throughout the 30 years or so that I've been at USC. I've have a lot of experience in these kinds of things, although there's, I think, in this review. Thank you.
Thank you. Dr. Zablotska, sorry. Probably way off.
No, you're very close. Thank you. I'm Lydia Zablotska. I'm a professor of epidemiology and also hold an endowed chair in preventive medicine at the University of California, San Francisco Medical School. Thank you.
Thank you. Next on my screen, Dr. Woloshka.
Yep, that's
Gail?
pretty good. I'm Gail
Okay.
Wallachak. I'm a professor of radiation oncology at Northwestern University. Most of my work involves radiobiology, molecular biology, and X-ray fluorescence microscopy. I'm also associate dean in the graduate school.
Thank you so much. Dr. Bruce Napier.
Hello, I'm Bruce Napier. I recently retired from Pacific Northwest National Laboratory, where for 47 years I was doing environmental health physics and working with Lydia and Dan and other people doing radiation dose reconstruction in support of epidemiological studies.
Problem. Oh, okay, I'm back. I guess it's my problem, right? My internet access problem. Okay, Dr. Bruce Napier. I don't if.
Oh, well, I just introduced myself, but I can do it again.
Okay. Yeah, no, that's all right. We have one-on-one introduction later. Dr. Will King.
Dr. Zhu, Will King is the contractor. So I think I will let, if you don't mind, if it would be easier, maybe Diana could go through anyone that we missed.
Okay. Diana, would you do that?
Well, we can just ask, do we miss anyone that that Dr. Shu hasn't called your name?
Hi, my name is Eric Franks. Apologies, there's no video from me. I recently retired from the Radiation Effects Research Foundation in University of Japan, where I worked for 25 years. A lot of work is solid cancer incidents after radiation exposure, and just my thanks for the opportunity to work on the committee and serve the public. Thank you.
Thank you. Anybody else?
Yeah, I'm Gus Potter from San Diego National Laboratories. I've been there for 31 years now. Spent a lot of time in internal dosimetry, some in external dosimetry. I also teach internal dosimetry at the University of New Mexico.
Okay, thank you. Dr. Shu can now do the agenda reveal.
Okay, now I do have internet problem. And my other screen got blanked out. Okay, so I think if I recall the agenda, the next is we're gonna have EPA to present the documentation or the guidance number 16 in terms of its process.
Hi, I'll just get started here. My name is Leanne Veal. I should introduce myself. I'm the director for EPA's Radiation Protection Division. I've been in this position since about 2017. My background is engineering. It's my second, I think, in the last couple of years interaction with the SAB, and many of your names are very familiar from the MARSIM document review that was so very helpful to us. I do want to also extend my thanks as a program manager within the agency to all of the panel members. The work that you do is instrumental in our being able to actually publish documents like Federal Guidance 16 and dose coefficients. And those then factor into as sort of bedrock material for our programs and our policies that we implement subsequent to that. For example, if the agency is asked to do a spent fuel disposal standard again in future, and hopefully that day will come sometime, the information that you're supporting here will factor into that. It's really sort of the bedrock, the science of the bedrock that we need to have in order to have our regulatory policies then implemented. I can't overstate the importance of the role that you play in serving the nation in that way, and I thank you very much for it. For this document, as mentioned, it's been coming for a while. The predecessor document and the Blue Book on radiogenic cancer risk models and projections for U.S. population, both of which have come through SAB reviews, are probably familiar to all of you. Work on this particular report, which is an update, began several years ago. It represents a huge investment for our program. We're not the largest funded program in the agency, and I do think we kick above our weight in a bit when you think about the kind of standards that we set for the federal government generally. We're very excited to have this draft in front of you. I do want to take a second to acknowledge some of the authors here. most notably from the Center for Radiation Protection Knowledge at the Oak Ridge National Laboratory. These individuals are here and available to answer questions along with our staff, which is currently being led by Dr. Arman Ansari, who came to us a little over a year and a half ago from the Centers for Disease Control and Prevention. And it's been a thrill to be able to bring him into the Environmental Protection Agency as the lead on our Center for Science and Technology. And our lead member of staff, Jonathan Nagata, who is also a student, as I understand it, finishing up his doctorate, who's going to lead us through the next steps for this. There's been a lot of researchers and practitioners who laid the groundwork for the development of this report. We're really building on the work of others in this, and those that contributed to the quality assurance efforts for that. We do have our quality assurance and science officer here, Jennifer Mosser, from the Office of Radiation Indoor Air with us. Also want to thank Diana Wong and the SAB staff office for keeping us on track and helping us even form and have this asset for the agency and for our program and for organizing the panel. Now, I also like to welcome Dr. Zhu. I know you are not new to the agency's science advisory boards or other boards, but looking at your background, I think it will be in good hands for getting this work reviewed and comments made back to the agency. For the panel members and your experience and your expertise to the advancement of radiation protection science. Thank you again in advance for all your comments. And I'll turn over to you, I think, Jonathan, for the next contribution.
Can I add a sentence here in between? Thank you, Dr. Veal, Ms. Veal.
Of course.
I have this incomplete introduction because of technical problems. Now I have my screen back, and I realized I was frozen out for a moment while you were talking. So my apologies again. All right, so now let's turn to Mr. Johnson Nagata. Thank you.
Hello there. Good afternoon and good morning. Can y'all hear me all right?
Yes.
Okay, fantastic. Well, I'd like to echo our division director's comments and thank you all for your willingness to serve on this radionuclide cancer risk coefficient panel and conduct a review of federal guidance report number 16. Diana and Will, are you sharing slides or should I? Okay, there we go. Give me 1 second here. All right, so my name is John Nagata. I'm a physical scientist at the U.S. Environmental Protection Agency, and I've been serving as project officer for the development of federal guidance products in the EPA Office of Radiation and Indoor Air. Our goal for the next few minutes is to provide a high-level overview of FGR 16. I'll note that in our in-person meeting in May, we'll be providing a lot more in-depth presentations about the components of the report, but for now, we're just giving a high-level overview. I'll also note that today I have a co-presenter for this session. While he is not listed on the agenda, I have the distinct pleasure of sharing the virtual podium with Dr. Derek Jokish to deliver our summary. Dr. Jokish is joint faculty at Oak Ridge National Laboratory Center for Radiation Protection Knowledge. And while I'm mentioning Oak Ridge, I should acknowledge that the Oak Ridge National Laboratory has really done the heavy lifting to develop FGR 16. And this collaboration is enabled by an interagency agreement between the US EPA and the US Department of Energy. So with that, we'll get into the presentation. Next slide, please. So the outline of today's talk, we'll begin with some background to provide a little context for this report. Then we'll delve into the FGR 16 methodology, summarize some key updates to data and models. We'll briefly highlight quality assurance efforts, and then provide an orientation to the layout of the report. And then we'll wrap it up by illustrating where this review sits in relation to the eventual publication of FGR 16. Next slide. And next slide. So we are starting with some background. The EPA mission is to protect human health and the environment. And with that broad charge, we have a dedicated cadre of professionals focusing on minimizing unnecessary radiation exposure to the public. The authority to promulgate regulations and to issue guidance is derived from a range of statutes. These include the Clean Air Act, the Safe Drinking Water Act, the Comprehensive Environmental Response, Compensation, and Liability Act, or CERCLA, also known as Superfund, and other enabling statutes. The authority to provide guidance on radiological protection dates back to the 1940s and 50s with the Atomic Energy Act. And the background image here is President Harry Truman signing the Atomic Energy Act in 1946. This responsibility of issuing federal guidance for radiation protection was formerly held by the Federal Radiation Council, but that was transferred to EPA at its creation in 1970. At that point, EPA was given the authority of advising the president with respect to radiation matters and issuing guidance to federal agencies in the formulation of radiation standards and in the establishment and execution of programs of cooperation with states. As such, the primary audience for federal guidance are federal departments and agencies in the US government with roles in radiation protection. However, the guidance is widely available to other stakeholders, including our state and territorial radiation protection programs, academic institutions, industries, and international radiation protection organizations as well. Next slide. The graphic here illustrates the radiation protection guidance issued by EPA since our agency's inception back in 1970. There were additional documents issued prior to this period, and those were published by the Federal Radiation Council, but they're not captured on this slide. There are two general flavors of federal guidance, policy recommendations and technical guidance. On the top part of this graphic are the former. These are the policy recommendations that are formally issued by the EPA administrator and signed by the president and published in the Federal Register. We have not published one of these since 1987. On the lower half of this timeline are the technical reports, and these are the sequentially numbered documents that provide tools for radiological protection, such as dose and risk coefficients. We're not going to go through these one by one, but I'm going to highlight some of our more recent publications. So starting at the right, Federal Guidance Report number 15, External Dose Coefficients, was published back in 2019. These dose coefficients serve as inputs to the risk coefficients for external exposure situations, which we'll describe in later on in this overview presentation. In 2014, we published FGR 14, which is guidance for diagnostic and interventional X-ray procedures. And in 1999, we published FGR 13, which we've previously referenced. And this provides cancer risk coefficients for environmental exposure to radionuclides. As you should know now, FGR 16 is an update and expansion of FGR 13. Next slide, please. The graphic here illustrates a generalized process for developing these federal guidance reports. Those top three boxes are preparation stages where we initially conceptualize a federal guidance report. We work to get approval and resources to proceed, and then we begin with planning. The bulk of the work comes during the guidance development phase, and depending on the nature of the report, this may include literature reviews and synthesis, developing models and codes to produce dose and risk coefficients, writing the report, and then conducting the necessary validation and verification under a quality assurance plan. Once the report is written, it goes to internal review and then moves on to external review stages. And this is where we are today, actively conducting a review with the EPA Science Advisory Board RCRC panel. Once we receive comments and recommendations from our external review, we make necessary revisions and changes, and then eventually move the report to finalization and publication. I'll note that we do engage with interagency partners and subject matter experts throughout this process, so these reports are not developed in a vacuum. And all of those stages are indicated with a little people icon up in the corner. Next slide, please. Moving into background on FGR16 specifically, the image on the right are some of those printed editions of the numbered federal guidance reports. FGR16 will be the newest volume in the FGR series, and it provides cancer risk coefficients for estimating radiogenic cancer risks, both morbidity and mortality, for environmental exposure to radionuclides. And as I mentioned before, it is an update and expansion of FGR 13, which was published in 1999 under the same title. Next slide, please. A few more specifics here. The report provides cancer risk coefficients for both external and internal exposures. We have 1,252 radionuclides addressed for the external exposures and 888 radionuclides for internal exposure from ingestion and inhalation. Compared to FGR13, FGR16 has an increased number of radionuclides and updated nuclear decay data, updated biokinetic models, dosimetric models, and US population demographic data. And it also includes updated cancer risk models based largely on the EPA Blue Book, which are themselves based on more than 20 years of data. Next slide, please. And here I'll highlight the different exposure routes that are covered under FGR16. We have inhalation, and this looks at particulates of fast, moderate, and slow absorption types, as well as vapor and gas for certain elements. Ingestion covers tap water intake as well as dietary intake. And for our external exposures, we address air submersion, ground surface contamination, and then soil contamination to an infinite depth. The risk coefficients in FGR16 are intended for individuals or organizations that need to provide population-level estimates of radiogenic cancer risks due to these exposure situations of radionuclides in environmental media. Next slide, please. So in this next section, we're going to transition into the methodology of FGR16. And for this portion, I'll be turning the mic over to Dr. Jokish.
Thank you, John. So I have the privilege of taking you through a summary of the methods used to arrive at FGR16 risk coefficients. And as John mentioned at the beginning, I will not attempt today to dive into all details of the modeling and calculations. The goal today is to provide an overview of the methodology. I anticipate this will help generate questions. Some of those, of course, we can try to answer today, but there may also be things you tell us today that you would like to hear more about when we see you again next month. Next slide, please. So I'll give you some time to read this disclaimer pertaining to the slides and remarks that I make today. Next slide. To arrive at a risk coefficient for radiogenic cancer, we need to address the following questions. First, for internal sources, how and where does radioactive material taken into the body move over time? Second, given radioactive material in a particular location, how much energy is absorbed in the tissues of concern? And note that this second question applies to radioactive material located either external or internal to the body. Third, given answers to the first two questions, what are the tissue-specific doses? And finally, what are the potential consequences of that dose and how likely are they to occur? Next slide. To arrive at answers to each of the four fundamental questions, we employ mathematical and computational modeling. For the first question, biokinetic models are developed to describe the movement of material through body tissues. The answer to the second question will utilize radiation transport simulations through geometrical models of human anatomy. The answer to the third question involves bringing together answers to the first two questions. And finally, models for radiogenic cancer risk are needed to address the final question. Next slide, please. So we're going to add a bit more detail to each step of the approach. I'll step through this flowchart over the next several slides, but for now, I want you to focus on the dark blue boxes, each representing a computer code module. In other words, a piece of code written at Oak Ridge which performs the necessary calculations. In lighter blue are data sets which provide input into the calculations, and arrows indicate the output from one module which serve as input to another module. Of course, at the end, we want a risk coefficient which provides either the risk per unit activity intake or the risk per unit activity concentration in the environment. Next slide, please. The first portion of this calculation addresses the first fundamental question for intakes of radioactive material. Where is the activity in the body at any given time? To answer, we need a couple of sets of models. The first set of models describe the physical decay properties of the material. ICRP publication 107 provides this information. We also need a set of biokinetic models for the element being considered. This code module uses that information to compute activity as a function of time for the radionuclide and its progeny in each region of interest in the body. So let's talk about those biokinetic models a bit more. Next slide, please. Biokinetic models are mathematical models which treat regions of the body as compartments represented here as a box. Material can move between compartments via the arrows on these diagrams. Each arrow represents a rate of transfer. On the left, you can see the biokinetic model for the respiratory tract, which describes how inhaled radioactive material moves through the airways, lungs, and associated tissues. Not shown is that this model includes absorption from each tissue into the blood, with the exception of the front of the nose, the ET1 region. Material can't get into the bloodstream from there, thank goodness. On the right is an example of a systemic biokinetic model. In this case, a structure typical for bone surface seeking elements, thorium and plutonium, for example. And not shown is a third model which describes movement through the alimentary tract. So each box is a mathematical compartment containing a time-dependent amount of material, and all the compartments are coupled to one another via first-order transfer coefficients. The model, therefore, defines a system of coupled first-order differential equations. The first code module sets up this system of equations and solves them to give activity as a function of time in each source region. Finally, I should note that one of the significant improvements to the biokinetic modeling is that we now treat radioactive progeny born while inside the body as having biokinetic transfers which are independent of their parent. In the previous iteration, the majority of radioactive progeny were assumed to inherit the biokinetic parameters of their parent. Next slide, please. The activity as a function of time then serves as input into the internal dose coefficient module. But we need additional models and their associated data to perform this step. First, we need to compute S coefficients, which rely on the physical properties of the radionuclide and its fractional energy deposition in body tissues. The latter comes from a quantity called the specific absorbed fraction, or SAF. The S coefficient, along with the activity as a function of time, are used to compute time-dependent internal dose rate coefficients. These dose quantities can be absorbed dose, effective dose, or to support FGR 16, RBE weighted dose. Finally, note that external dose coefficients come from FGR15. Next slide. For internal radionuclides, the RBE-weighted dose rate coefficients are computed using this equation, and we'll walk through each term in this equation from left to right. We're after the RBE-weighted dose rate coefficient to a target region R sub t as a function of time. The coefficient means we want the quantity to be per unit activity taken into the body. So we divide by A naught, which is that initial intake activity. There are two summations. The first over I covers the case where the radionuclide that is ingested or inhaled has radioactive progeny. In that case, the I summation handles the parent and the contribution from subsequent radioactive progeny, which are born inside the body. The second summation is over all the source regions as defined by the biokinetic models. Inside the summations, we have the product of two terms. The first is the output from the biokinetic module. The activity in each source region, R sub S, as a function of time. The second term is the S coefficient. It provides the RBE-weighted dose rate to a target region per unit activity in a source region. Note that it is also potentially time-dependent since we account for intakes in reference children whose tissues subsequently grow. Finally, note that the RBE values were made in consultation with ORIA and are designed to be consistent with the cancer risk models. Next slide, please. The last code module computes the risk coefficients. As input, it requires the aforementioned RBE-weighted dose rates. It also needs information on lifetime attributable risk, or LAR, usage data, and US survival probability functions. Next slide. A few important takeaways about the risk calculation. Note that risk per unit exposure to our representative person exposed throughout life to a chronic environmental source is mathematically equivalent to the average risk to an entire population of such persons resulting from an acute exposure. There are 15 cancer outcomes, and the risk to each is computed separately. The calculation accounts for age dependency in dose rate, usage value, and LARs. The calculation also accounts for the chance that someone may die from a non-radiogenic cause before a radiogenic cancer is observed. And a few key assumptions. The consequences of radiogenic disease contribute negligibly to the survival function. For chronic exposures, the environmental activity concentration is invariant with time, and the population distribution is constant over time. Next slide, please. We call this suite of computer modules QCal. QCal was originally intended to serve as QA for the DCal codes, but over time it became clear that QCal was the correct choice for performing FGR16 calculations. The QCal codes have been extensively used to support ICRP dose coefficient calculations, which has provided us with the opportunity to perform valuable comparisons with independently written codes in Europe. Chief amongst them are colleagues in the United Kingdom and Ukraine. Next slide, please. So this slide can be overwhelming if we try to follow every arrow, so let's not do that. The intention here is to give you a flavor for how much input data feeds into the various steps in the calculation and where that data is published. And you can see the majority of it is published by the ICRP. A couple of examples of data which was developed at ORNL and published by the ICRP The systemic biokinetic models are published in the ICRP OIR and forthcoming EIR series. And the specific absorbed fractions appear in publications 133 and 155 and are largely based on radiation transport in the ICRP voxel phantoms of publications 110 and 143. Next slide. So this is not a great slide to verbally go through, but if you want to print out a single slide which summarizes the methodology, this is the one you want. All the code modules are in the center, and we've attempted to list the various input data in green. Next slide, please. So while I've teased a few examples already, the next few slides summarize the methodological changes from FGR 13 to FGR 16. Next slide, please. FGR 13 used decay data from publication 38, but we now have the significantly more robust and vetted publication 107. The SAFs used in FGR 13 came from a variety of sources. They now come from the most recent ICRP datasets, which in general rely less on mathematically stylized models of anatomy and more on image-based models. The latest SAFs also have energy-dependent values for electrons. Next slide. The respiratory tract model has had a few improvements which appear in publication 130, but the overall structure is still that of publication 66. The alimentary tract model in publication 100 is significantly more complex than the simplistic version necessary in 1979 to perform these calculations. And the systemic biokinetic models have seen changes from the mid-1990s series of publication. The extent of these changes varies by element. As noted previously, the assignment of independent biokinetics to radioactive progeny is a significant improvement. Next slide. External dose coefficients used in FGR 13 came from FGR 12. For FGR 16, the external dosimetry of FGR 15 is used. Usage data now comes from the EPA Exposure Factors Handbook. The US population data, which informs the survival functions, has also been updated, as have the cancer risk models. Next slide. I suspect I've convinced you there is an abundance of data and codes which we use. It's worth spending a little bit of time summarizing how we gain confidence that the calculations are giving us numbers consistent with the various modeling decisions. Next slide. Our QA efforts fall into one of these four general categories. I'll take you quickly through 4 examples of things we do to give confidence in the risk coefficients. Next slide. First, how do we ensure the input files are correct? Well, we use the same files the rest of the ICRP codes use without any customization. We also keep those files in ASCII text format and use time date stamps inside the files. A tool that has proven very useful is the use of Git repositories. In FGR 16 work, we've used these to support both data and code development. If you're not familiar with Git, it maintains both a local and cloud repository and automatically tracks all changes made to files. Anytime a change is made, it prompts the user to provide a description of the change and its basis. Next slide, please. We have also performed a large number of internal and external comparisons. When we developed new codes, they were benchmarked against existing codes. So for example, in writing the risk coefficient module, a new code used FGR 13 input data to reproduce FGR 13 risk coefficients, which was useful since the mathematics of the risk calculation has not changed from 13 to 16. In addition, 2 codes were written by different individuals with results compared for agreement. And I previously referenced the tremendously valuable external comparisons with our ICRP colleagues in Europe. We compared dose coefficients, but these comparisons also looked at intermediate quantities in the calculation. By looking at the number of nuclear transformations, we gain confidence in the biokinetic module. By comparing S coefficients, we gain confidence in the S coefficient module. Next slide, please. Earlier, I emphasized that we are using data and models which appear in publications. All of those publications involve peer review as part of the publication process. On the right, we've highlighted a flow chart which describes the ICRP publication process. This process involves multiple reviews from individuals and groups, both internal and external to ICRP. Next slide. And I'll end my portion of the presentation by sharing an example of our external comparisons. Plotted here are the percent differences between QCal internal dose coefficients and those computed in the UK and Ukraine. On the horizontal axis, various radionuclides and chemical forms are grouped by element. On the vertical axis are the fraction of cases compared. The colors represent the percent differences. So in total, 96% of these cases have agreement within 1% of each other. 99.8% of the cases have agreement within 1.5%, and all cases agree within 2% of each other. This gives us a lot of confidence that the data and models are being implemented in the same manner as our colleagues in Europe, and that the computational methods utilized by the codes are acceptably consistent with one another. So with that, I will turn it back over to John.
All right. Thank you, Derek, for running us through the methodology, the data updates, and the QA considerations. Next, I'm going to briefly describe the layout of the report. So next slide, please. So if you haven't had a chance to review the draft report, this table summarizes the layout. For each chapter listed, I've provided a brief description, the page count, and corresponding charge questions. Chapter 1 of the report is the introduction, where we provide some background, an overview of the approach, discussion of appropriate uses of the risk coefficients, and a brief section on uncertainties. Chapter 2 includes the tables of risk coefficients. 3 tables are provided, one for inhalation, one for ingestion, and one for external exposure situations. Owing to the large number of radionuclides considered, this section of the report is quite lengthy. It accounts for over half of the report's total length. At this point, I should make an important note that the risk coefficients provided in Chapter 2 of the draft are not yet final. While they have undergone a very rigorous QA review, we nevertheless anticipate making changes and recalculating the values based on feedback from this review. Additionally, we know that a recently discovered issue with a subset of the external dose coefficients, those provided in FGR 15, will require recalculation of the external risk coefficients. The remaining chapters of the report provide details on the data and models employed to arrive at those risk coefficients. Chapter 3 describes the different exposure scenarios and usage data. Chapter 4 describes the biokinetic models. Chapter 5 and 6 detail the dosimetric models for internal emitters and external exposures, respectively. And Chapter 7 details the cancer risk models. We have an appendix that gives some examples of application by providing a few sample calculations. And a glossary and references are provided at the end. The total report length is presently 274 pages. Next slide. And to wrap up this overview presentation, I do have a slide to illustrate where this report will head after the SAB review. Next slide. So on the FGR16 publication process, these are the stages leading towards the publication of FGR16. These are steps post completion of the draft. We conducted an internal review that is within EPA. Following the EPA review, but before this SAB review, the report was shared with and reviewed by federal departments and agencies through the Interagency Steering Committee on Radiation Standards, and they provided some very useful comments, which we are continuing to work through. We're now at the EPA Science Advisory Board review through the Radionuclide Cancer Risk Coefficients panel. Once we make revision based on the comments received, the document will go through the EPA action development process. And while this process is primarily intended for rulemaking, FGR16 will be evaluated for its potential policy significance. And depending on a determination by the EPA Office of Policy, FGR16 may be subject to review by the White House Office of Management and Budget. Once we've completed all of these review steps, the document will be finalized and published. Next slide. So I hope this overview provided some context for the review of FGR16. We look forward to providing you with more detailed presentations on elements of the report at the May meeting. So thank you.
Thank you, John. Dr. Xu, are you with us?
All right, I said something but forgot to unmute. Well, thank you very much, Jonathan and Derek, for presenting this overview of FGR16. It's been very, very helpful. And we're actually 10 minutes ahead of the schedule. So I think we have plenty of time to let the panel member interact with EPA people in terms of comments and questions. Please raise your hand. Dr. Napier.
Thank you. This is probably too detailed a question to ask here, but it was a point I would maybe like brought up in the in-person meeting. Is that I've actually used Federal Guidance 13 for many years, and I have written very similar codes to the things that have been described. One thing that I've always been a little bit fuzzy on, because I'm a dosimetrist and not an epidemiologist, is why we have separate entries for drinking water and for consumption by food. Because when normalized back to a single becquerel intake, one might think that you'd get the same answer, and we don't. So, at some point, I would like a little more detail. And I'm assuming it comes down to the exposure scenarios, but I haven't quite wrapped my head around it yet. So a little more detail on why we need separate entries for drinking water and intake by food. That was my point.
Thank you, Dr. Napier. Dr. Little?
Yeah, I would just appreciate a bit of guidance as to what precisely you're expecting from us on the when we meet at the end of May. Do you want a sort of just a document in which we go through the relevant sections of the report and just comment on particular things? Sort of more or less line by line critique of the relevant parts of the report, or what?
Yes, thank you. The charge questions, which we'll be reviewing, I think, later in this meeting, are intended to serve as general direction for the feedback we'd like on the report. And Diana, perhaps you can speak to the agenda for the May meeting, if that would be helpful for Dr. Little.
Well, I think what Dr. Little is asking is that do you want them to answer the response just by looking at the report and looking at line by line, or look at the big picture? From what you're saying, it seems like you're asking for the direction, so it's more like big picture question. Is that it, John?
Yeah, I think so. Most of our charge questions focus on the methodologies and data sources used in the report. So in that sense, I'd say those are bigger picture questions and less about the line by line what's written in the report, though we want to make sure that the report as written effectively communicates the justification and application of the models and data selected.
I mean, the other thing is that are we expected to? We are, the lead writers are presumably expected to put together something, some document which will comment on the charge questions that's assigned to us. Would we be expected to come to the meeting having at least an outline of this prepared, or are we expected just to put it together based on the discussions that we have then?
Diana, you want to comment on that?
Yeah, I think yes. I think Mark's question is really perhaps will be answered during the next step discussion at the end of the meeting. What I expect the discussion to prepare for the next meeting. So perhaps we should hold on for this, and now perhaps we should focus on clarifying question on what EPA has presented. Do you have any questions to ask about the material, so that you have better understanding of what is involved? Or perhaps you can ask the EPA to answer some questions that they have to prepare and then bring the answer to the main meeting in May.
That could be a process, even if we don't have them. I mean, after the meeting, if you come up with some questions for EPA to clarify, we can always send to Diana Wang, so that Dr. Wang, so that EPA can prepare.
And
go ahead, Jonathan.
I've made a note to look into this question about the separate numbers for food and drinking water, and we can prepare a response to that. Thank you.
Now, I think Dr. Little made a point that resonates with my comment. That is, when the panel do complete the review and come up with comments and a critique, and I wouldn't be surprised. Some are mostly just editorial for clarification, for brevity or clarity of presentation. Some would be technical but easy to clarify and modify, and some may represent different view or perspective in terms of approach. So to what extent EPA would say, I'm only looking for something that I can act on within a very short period, versus say someone comes up with a critique that fundamentally disagrees with our approach. And although we agree, maybe you disagree, but even if we agree, it will take years to address or respond to that. So what's the EPA's position on that sort of a thing?
I think ideally we would look for feedback that could improve the approach we've taken in the draft FGR 16 without fundamentally changing the the paradigm under which we develop our risk coefficients or approach risk assessment for radiological hazards. So practical recommendations for how to improve FGR 16. That may have been a non-answer to your question, but that's the best I have at this moment.
Okay, so well, actually, I've frozen out for a moment. Every time we need a technology, it fails you, right? I mean, welcome to New Mexico. So I guess my interpretation is that low-hanging fruits to improve the guidance documentation or FGR 16 is really what you're looking for. You welcome, strategic recommendations, but that may not be something you're going to address right away. Is that a fair statement?
Yes, I think yes, I think that's a fair interpretation. Yes.
Okay. Any other comments, questions?
Well, I had a question just about there's 1,252 radionuclides, and you want to get risk coefficients for each one of them. Where does epidemiology stop and just modeling begin? Modeling without data. I can't imagine that there's going to be information on all 1,252 radionuclides. If someone could take that question, I'd appreciate it.
Excellent point. Jonathan or Derek?
I think I can provide an answer. The epidemiology would not be radionuclide specific, right? So the underlying epidemiology would be relying on the dose quantity, right? So the 1,252 radionuclides, we compute dose for each of those radionuclides, or the 800 some for internal, and then the cancer risk models are based on the dose quantity. Does that help?
Yeah, that clarifies some of it anyway. The RBE information, I think.
Yes, and
it used to be brought into that.
Yeah, I think that's something we would like to go in more depth with you next month in person, is explain the RBE quantities that we've used in the calculation.
Dr. Banky?
Okay, yeah, thanks for the really nice overview. This is just a clarifying question for slide 13 on the generic code modules. Do they apply for the cancer risk to the skin? Or are there specific aspects of skin that would change that slide?
I am quickly trying to pull up the slide just so I can see specifically.
Yeah, it's a very helpful graphic, like many of them, detailed, but if there was something different for skin, that definitely could be captured in the briefing next month. Just curious if you knew off, hand that still applies. That'd be great.
Right. No, I think that's a good question. I'll attempt to answer it very generally, but I think your point will remain about you'd like to hear more about the skin cancer risk model, right? So each radiogenic cancer type has its own model that informs the cancer risk, right? So dose to the skin is computed, and then a cancer risk model for the skin is applied to those skin doses.
Okay, sure. Yeah, that definitely came through in the presentation. Okay, sure. If there are differences with respect to the structure by which the dosimetry for skin is accounted for, that would be a useful slide. Okay.
Thank you. Gail, I'll try to.
Yeah. I have just a general principle question, and that is, are we supposed to be looking for holes in this report where things that should have been covered aren't, or where there are missing pieces, where there are things known? Like, I'm thinking about, I didn't see it. It might be in the report. I haven't looked at the report in much detail, but things like size of particulate for inhalation makes a difference in biological responses and in clearance rates and things like that. I can imagine that not all of that could possibly be covered easily. Are we looking for places where important things are known that maybe haven't been included or can't be included because they're not understood in the human system?
I think if you have recommendations based on gaps, things that we may have missed, we would be open to those recommendations, would appreciate your expertise and input.
Okay, thank you.
I have a follow-up question following on Dr. Bankin and Dr. Little. That is, you look at so many radionuclides. When you come up with these estimates of coefficients, do you actually sort of rank them or categorize them based upon your confidence or quality of the estimation? I haven't read the report in great depths. I just wondered if you have that in place or not.
That's a good question. We do not have a ranking of the quality of the estimates for the risk coefficients, but we do have a discussion on estimates of uncertainties around those risk coefficients in chapter 2 of the report.
I see. Then I think I would like to hear more, when we meet in person, because if we just throw all these coefficients to the practitioner, it's up for them to make a judgment whether this is reliable or this is just a rough estimates. Then on that note, and I missed it if I apologize. You didn't mention that there's a couple of tables that are requiring recalculation. Is it self-evident which tables they are?
They are not indicated as such in the draft report.
Okay.
No.
Maybe for the reviewer, you want to indicate to us just that people are aware that these still are sort of in a non-complete stage.
Thank you. I've made a note.
Yeah. All right. Any other questions, comments?
Hello, this is Dan Strom. Can you hear
Hi.
me?
Yeah.
I had maybe a frivolous question, but I think the life tables that are used are pre-COVID. Would that make any difference if we looked at the fact that a whole bunch of old people died of COVID and lived to get cancer? Would that change anything?
Thanks for the comment and question. I'm going to have to have our team take a look at that and provide a response later.
Great, thank you. Dr. Grant?
Yes, thank you very much. I admit I have a lot of reading to do, but I was struck a little bit on slide 21 regarding the final steps, these additional input for risk coefficients. It relies heavily on this EPA blue book, whereas I might, I guess, naively have thought there would be a lot of other input each of those steps. Maybe the EPA Blue Book already incorporates all of this. I guess I'd like to just, at some point, I need to do some reading, but I'd like to know how that EPA Blue Book is put together and how up to date that is compared to all the important work that we've done to get to this point with the rest of the EPA.
Yes, thank you. We, if it's all right, we'll work on preparing some summary of the cancer risk models, those in the Blue Book, and then modifications that were made in FGR 16 for the May meeting.
I have a quick question, if that's okay.
Yeah, Harry, go ahead.
I was wondering if you guys are worried about the public reaction to use of the LNT model, given all this stuff that's going on these days in the Health Physics Society right now and that kind of thing.
Yes, that's an interesting point. This is something that we are aware of, and EPA has previously made statements about the use of LNT for radiation protection purposes. We are not looking to get into a debate about LNT and its application. However, we're cognizant of the sensitivities around this issue.
And do you provide uncertainty estimates for the cancer risk coefficients per unit dose?
I do not believe we have that in the current draft.
Okay, that might be something to think about.
I guess you only provide a qualitative discussion of uncertainties.
That's correct.
Okay. Yeah, I mean, this might be a question that we're going to invite you back to, lead a more in-depth discussion. Dr. Strom?
Thank you. I looked at the uncertainty categories, the A, B, C, D, and E categories of uncertainty. And I have some, first of all, technical questions about those. I was fortunate to have dinner last night with David Powell, who in 2007 was the lead author on those uncertainty values. And these are ranges where you talk about the 95th percentile or quantile and the 5th quantile, and you take the ratio of those two, and if it's less than 15, then it's an A. If it's over 115, it's an E. But those are absolutely useless for uncertainty propagation. If I were to do a calculation with these coefficients and somebody said, well, what is the uncertainty on the coefficient that went in? The values that are in this report are not usable for that to answer that question. You can't use them to propagate through a model. And I'm wondering if that's one of the concerns I have, and I'm wondering if that's a significant concern. Thank you.
It was not a concern until right now. I think this is the discussion on uncertainties is one of the topics of the charge questions, and certainly something we'll have to delve into further as we proceed with this review.
So in other settings of risk assessment, EPA tend to use sort of low confidence limit to address sort of this type of uncertainty. So have you considered that approach? Maybe this is something. I'm sorry. So maybe this is something we can discuss in more depth.
Yes, I think this is something we'll need to discuss at a future time.
We're still ahead of time, 10 minutes, 9 minutes before break, but we could always take a longer break if unless we have more questions, comments that we want to engage with EPA. All right, hearing now, maybe the implication is that we prefer a longer break. Oh, Dr. Dan Strom again.
I have an editorial concern with this document and with many documents, and that's the glossary. And the problem is every entry in the glossary begins with a capital uppercase letter. And you can't show me a single dictionary on planet Earth where every entry is capitalized. The reason the letters are capitalized in the glossary is because Microsoft Word's autocorrect does that for you unless you defeat it. And many things are not properly capitalized. Any SI unit, for example, that is named after a person is spelled with a lowercase letter when it's spelled out. For example, Gray, Siebert, and Becquerel. Those units are required to have uppercase letters to begin with. All SI units have an uppercase letter or symbol, at least the first one. And so this is a problem in this glossary and a zillion other glossaries. But if anybody ever tried to figure out how to use these words, the glossary is not going to help you because the words are mistakenly written as uppercase. So that's just an editorial concern, but it always drives me nuts. Thanks.
Thank you. Well, hearing now, maybe we're ready for the break. Dana, any suggestions?
Yes, we can have a break because we don't have any public comments. So, we can have more than 15 minutes break. So
yeah, so we can still come back at the 2:35 as scheduled.
Come back at 2:35 because right now it's almost 2:30.
Oh no, sorry, 2:50. So I was reading the wrong line. We're supposed to take a break at the 2:35, so we are a few minutes, 7 minutes earlier. All right, so if we don't have anyone making public comments, we might be able to shorten the meeting and end the meeting earlier. So Dana, are you okay if we just come back at the 2:50?
Yeah, sure.
Okay, great, thank you. All right, see you at 2:50 then. welcome back. Dana, are you there now?
Yes, I'm here. I think we can start.
Okay, great. I think Dr. Brennan is here. Do you want to say a few words?
I do. Thank you. As kind of mentioned, I was kind of double booked at this time, but Dr. Zhu, thank you so much for chairing. And that's a lot of responsibility. And I'd like to thank everyone here for their public service to taking on this important review. And it sounds like it's going great. I came in at the end of the presentation and I'm enjoying the meeting and, go after it. That's it.
Great. Thank you so much.
Sure. Thank you.
Yeah, we look forward to working with SAB and the staff and EPA closely. Dana, do we have anyone who wants to make a comment?
No.
No?
We can just proceed with the discussing the charge questions.
All right. So without any comments, let's move on to discuss our charge questions. I suppose that we have all read the charge question to some extent, and I wonder if EPA should present the charge question to us, and let's walk through them one by one. I can always volunteer to read them, but if EPA has a better way of doing that, that'd be great.
I'd be happy to read through them if you prefer, or I can
That'd be
leave that to
great.
you. Okay.
That'd be great. And when you're tired, just tell me and I'll take it over.
Wonderful. Thank you. So the way these charge questions are organized, question 1 includes 5 parts, the first 3 which are mentioned here. And for the overarching goal of charge question 1 is to discuss whether updates to models and data sets were appropriately incorporated into the FGR16 methodology. Part A of question 1 is, are updates to exposure scenarios, which is covered in chapter 3 of the report, appropriate, and do they comport with the recent literature? Have they been described in sufficient detail? And is justification for the selection of data adequately discussed? Part B focuses on the biokinetic. Go ahead.
Jonathan, can I make a suggestion? It's just my suggestion. Maybe we should let the panel to focus on 1A. If we feel it's okay, then let's move on to 1B, one thing at a time. Would you be okay with that?
Absolutely. We can go through these one by one.
I saw my name as being the lead discussant on 1A, and at the moment I don't have any problem.
Okay. Any comments on Dr. Dan Strong?
Hi. One of the things that is about our biokinetic models in patient protection is that we don't accommodate the lactating mother, the mother who is nursing an infant. In the chemical world, this has been standard in EPA models for 5 decades or more. And there are a couple of radioactive materials that are selectively excreted in breast milk, iodine and pertechnetate, that's technetium in the form of TCO4 minus. The pertechnetate is not organophile in the thyroid, so no big deal. It does change the biokinetics. And up to 25% of the iron and technetium in a woman's body is secreted in breast milk when she's nursing. And so, that's not in the
I can't not hear Dr. Stram. It's just me or everybody.
I think Dan just kind of fell off the network here.
Okay. So I'm the only person who had an internet problem. Well, maybe let's see if we have any other comments when Dr. Strum comes back, and we ask him to start over. Jonathan, I do have a question related to all the questions because, I read the documentation. The update is largely based upon data and a model, maybe some other, government-related reports. And I don't really see if EPA took for example, a systematic review approach to update the literature. Yet here, 1A, it says, do they comport with recent literature? That is a huge question because in my mind, if you did not do a systematic review, I would have no way to say, I believe, you have exhausted or you have reviewed all the most recent good quality literature for me to make that judgment. So I'm not sure what's in the report and what to actually do, but from outset, it looks like it's mostly just model and a data update. Does that cover literature review or not? So I wonder if this has some implication to the charge of questions. Because if you ask me if it's comport with literature, I have to dig into that, right? And yet we are not supposed to do our own literature review. We rely on your report to say, you did this.
Yes, that's understood. And it is, I imagine, outside the scope for the SAB to conduct such a literature review as you're suggesting. So perhaps that warrants a visit at the way that this question is framed, such that it doesn't imply that such a literature review is necessary.
Okay, I think Dr. Strom first, and then Dr. Simon. Dr. Strom, we lost contact with you. Can you start over again?
Yes, my concern is that ICRP biokinetic models do not include the lactating mother.
Okay.
The woman who is secreting radionuclides in breast milk that are taken in by an infant. We've had lactating woman models in chemical toxicology for decades. They're a primary thing for EPA in regulating chemicals, but ICRP has never caught on. And in particular, iodine and technetium in the form of pertechnetate, TCO4 minus, are selectively concentrated and secreted in breast milk. 25% of iodine supposedly comes out in breast milk. And so this is not an ICRP model. So what do we do about this? To me, a glaring omission in this document. I don't know what, that's outside the scope of this review, but still it bugs me. So thank you.
Can I ask you to clarify? Is this what your reaction to this review question, a charge question after, and then this is what you see in the report, but you don't have a question, you don't have issue with the charge question, do you?
It's charge question 1B.
Oh, okay. We're still at the 1A. Can you maybe make further comments?
I'm sorry.
Okay, so Dr. Simon.
Thank you. I don't know that I want to modify the question, but I do want to comment that the questions, at least so far, put a tremendous weight on ICRP publications.
Right.
And ICRP publications do have a high standard, but there is a tremendous amount of literature out there, and it's very difficult for most of us to know whether literature that we're familiar with is even in the ICRP publications, because who of us has time to actually read all those things, all those reports, search for something that we think is very important and know that it's in there. And if it's not in there, what do you do next? So I guess the point I want to just raise is that I would hope that EPA would be interested in our opinions about a wide range of literature, not just ICRP reports. And I realize this isn't exclusive, but it says notably. So I already have one example in my mind about an NCRP report, for example, that's not cited in this. I can't tell you whether it's in an ICRP report or not. So I just want to make the comment that I would hope that these questions would elicit from the review group their knowledge about publications other than ICRP.
And can I just add to that? So this is Gail. I'm on ICRP, but I agree 100% with what Steve said. A lot of the reports are being updated. I mean, like, for instance, the report on DDRF is very, very old, the one that's there. It's taken us over 10 years to get that report updated. A final report is still not published. If we don't depend upon the current literature, we would be lost with that old report. I'm on the committee chairing for RBE. The last RBE report was before 2002. I mean, that information is old. That's why we're updating it, but we're going to be years updating the report because it's a voluntary group, and that's how timing goes. So I agree with Steve. I think we need to look at a broader literature than just ICRP.
Thank you.
Okay, so Jonathan, sounds like this is not necessarily, a suggestion for changing the charge question, but the implication of this charge question is that we're going to look into all the literature, and you might. I don't want to say you might get dinged, but so I think a full disclosure of how do you update with regard to broader literature would be really important.
Yeah, thank you for that. That's a concise summary there. And I do think we appreciate drawing on the knowledge of the panelists and other areas of the literature where we may want to take into consideration incorporating updates beyond what we have.
Okay, so so is it fair to say that we're not necessarily suggesting you change the charge question 1A, but you want to clarify a little bit more so that we know exactly what the scope would be?
Yes, I think we can work to clarify, because we would like to have those perspectives, but perhaps without implying a full literature review for each one of these sections. That's understandably a monumentous undertaking.
Yeah. Okay, go ahead. Do we have any other comment on further suggestion for question 1A? Well, hearing none, then we move to 1B.
Yes, question 1B is structured similarly to 1A, with a focus on biokinetic models. So are updates to biokinetic models covered in Chapter 4 appropriate, and do they comport with the recent literature, including but not limited to ICRP publications? Have they been described in sufficient detail, and is justification for model selection adequately discussed?
Thank you. Now we go back to Dr. Strom. Sorry, we make you speak 3 times.
Well, I just think that the models are incomplete because they do not include the breastfeeding woman and the nursing infant, where it's a peculiar radionuclide pathway. We know it for iodine and for technetium as pertechnetate. They're both concentrated in secretions in breast milk. And so the nursing infant gets an especially high dose of these radionuclides. And that, you know, as I've said, in toxicology, the secretion of, in particular, pesticides in breast milk has been a concern for decades. So I would like to see, you know, if not in this work, I would like to see EPA tackle this question for radionuclides. And I'd like to see ICRP and NCRP do it as well. So thank you.
If I may, Dr. Strom, you almost single-handed answered that question, or at least an important aspect of that. Are there any committee members have recommendations, suggestion for question 1B in terms of clarifying, setting down the scope, and so on and so forth? So the comments for 1A to some extent also applies to 1B, right, Jonathan?
Yes.
Okay. Well, here and now, maybe we should move to 1C.
1C moves to the dosimetric models for internal exposure covered in Chapter 5, whether they're appropriate and comporting with the recent literature, notably ICRP publications, and have they been described in sufficient detail?
Right. The same structure, the same type of questions. Any comments, suggestion, clarification? Dr. Simon?
Well, I just want to reinforce what I said earlier. I was actually looking at 1C when I made the comment about the completeness of the literature. So that really applies to all 3 of these sub-questions.
Excellent.
And I think Dr. Zhu, you know that, but I just want to be clear about that.
Yeah. We'll make sure that EPA is aware of that. One thing I think you and Gail made it very clear. I learned a lot. That is why. My question: why ICRP publications standing out? Are they up to date? That sort of thing. But that's our review process. So we're gonna answer these questions. But as long as I think we're not confused by questions, I think EPA is doing a good job. All right, shall we move to 1D? Let's do that.
Yes, again, similar structure. Are updates to dosimetric models for external exposure appropriate, and do they comport with the recent literature, notably Federal Guidance Report number 15? Have they been described in sufficient detail, and is justification for the selected approach adequately discussed?
So this is Eric. I'm in charge of this section, and yeah, similar scope issue regarding the literature search is the problem. But and
Erica, Erica, I have trouble to hear you. Can you move closer to the microphone, maybe?
Yeah. I have a bad connection, so I'll write my questions. Thank you.
Diana, I remember you were saying that we have to somehow formulate the question, our comments, the proposal for charge a question at this meeting. Are we okay if Erica sent his comments later?
No, because we have to have
Okay.
the question. If he wants to reword it, then the entire panel can discuss, because we
Okay.
cannot discuss, you know,
Okay.
not in the public setting. So if he's listening, he should just propose his wording right now, or
Okay.
somebody else can propose it. Because we're not going to have another meeting to discuss the charge questions.
So this had to be a committee discuss. Okay, Dr. Eric, can we invite you to speak again despite internet problem? He probably signed
This
off.
is Eric. I think, yeah, let me try via writing directly with EPA. It's my connection.
No, that's not the way it's done. Actually, I can hear you very clearly right now.
Yeah, it's a lot better.
Okay.
So why don't you just speak?
I switched computers. So I'm in charge of, and I'll rely on my colleagues to get through this. Similar issue with the scope of the literature search, and the reliance on particular reports regarding a more broad approach. But we'll do the best we can with what we've been asked to do. So we'll go from here. Thank you.
So your suggested change is similar to what we have proposed to EPA on 1A, 1B, 1C, right?
It's the same issue for all of these questions.
Okay, okay, sounds good. All right. Any additional comments on 1D? Since if not, then let's move to 1E. Dr. Simon.
Yeah, I'm reading these questions or rereading them, and I'm wondering, this may be too early to be discussing this, but I'm wondering what EPA will do depending on our answers. What if we said no to one of these questions? Have they been treated adequately or something like that? So I'm wondering if the question should also include, do you, meaning you as the reviewer, have a recommendation for a remediation or a solution? Because I don't know what will happen if we come back and say no to things. I don't know what the threshold is for EPA to have to, completely redo a model or add a new pathway. So I'm just wondering if EPA would want to include in the question a request from the reviewer for a possible solution.
I think I can answer that. I think I can answer that. In a typical SAB report, okay, after the discussion, the panel members will typically give recommendations, and the recommendations are usually divided into 3 tiers. The first tier recommendation is that the EPA should consider the panel's recommendation and do something about it or change the document, before they can finalize it. And the second tier is T2 recommendation, is more like suggestions. Is that it's good that EPA will consider it, but it's not as a strong recommendation as a real recommendation that they have to do it before they can finalize the document. Okay, so that's tier 2. It's more like a suggestion. And then for tier 3 recommendation is for future. It's something that they cannot do right away. We may take some time to do it, so that there will be a tier 3. So you'll be in the future, not in the near future, but sometime in the future, because it may take some time for them to do it, to collect more data and so on. So that you can have recommendation, but then you can have 3 different tiers. So am I answering your question?
Okay, great. Dr. Simon, you're muted, but I see you nodding your head. So I think this is excellent explanation. And Jonathan, maybe, a clear statement as a front matter, just say, if you make recommendations, designate, this is my suggestion, designate your recommendation into one of these 3 tiers. So that way, it also reminds the panel members that when we make a recommendation, we recognize this is a low-hanging fruit. EPA should act on this before finalizing, as part of the process to finalize documentation versus a strategic recommendation for the future. Does that capture what we have discussed here so that it's very clear? You're looking for different type of recommendations. We are mindful the recommendation that we're making to help you get to the finish line.
I don't think EPA has to include that in the charge question. In our report, we'll do it ourselves. We will categorize recommendation in 3 tiers ourselves.
Either way, I mean, if we have this mutual understanding, whether it's in writing or not, but I've seen charge question that EPA submit to Academy of Science, for example. They always say, this is the scope, this is the tiered recommendations. So, but I'm okay either way. But I want to present this to the entire panel so that we're mindful about, the feasibility of our recommendations. Okay, so Jonathan, this is back to you and Dana about how do you word it. But I think this is an excellent comment from Dr. Simon. Okay, we're done with 1D, right? Oh, we're done with 1E. Well, we're gonna talk about 1E then.
Yes, 1E asks, are the radiogenic cancer risk models in Chapter 7 consistent with the EPA Blue Book and VIR 7? Were updates to the thyroid and bone models appropriate, and do they comport with recent literature? Have they been described in sufficient detail? And is justification for model selection adequately discussed?
Comments from Harry. I don't see your last name, sorry.
Harry Cullings. Yeah, I'm still a little worried that this model presumes that the authoritative guidance on risk per unit RBE weight dose is the EPA Blue Book and VIR 7, and I'm not familiar yet with the EPA Blue Book, but VIR 7 is almost 20 years old. So I'm just wondering a little bit about that.
Any clarification from Jonathan?
If I'm hearing correctly, it sounds like this is less a concern about the way the question's written and more about whether or not the panel will determine that the EPA Blue Book and VIR 7 are not the most recent models to employ for the risk calculations.
Yeah, that's correct.
Okay.
Okay. Dr. Little and then Gail.
Yeah, I had similar concerns, but I specifically wondering why the emphasis on thyroid and bone models, particularly. I mean, there's all sorts of other cancer sites that might be mentioned.
Yeah.
Why were these two singled out?
The reason those two were singled out is we did use updates to those models beyond what was published in the Blue Book. So the cancer risk models for FGR16 are mostly derived from the Blue Book, with the exception of the thyroid and bone models, which have been used publications in the literature after the Blue Book was published.
Yeah.
Yeah, I had the same points. I mean, the VIR 7 is so old, and there's so many things that are not accurate in VIR 7 anymore. I don't know why we would be comparing to that and not to more recent literature. I don't know. I'm just expressing my frustration with the question.
All right. All these are probably have more to do with the implication of our review. The question itself is clear, I guess. Okay. Well, let's see if we have any comments, suggestion for question 1. If not, we're ready to move to question 2. Thank you for the very constructive discussion and EPA's response. All right. Let's move to question number 2 then.
Question 2 is focused on skin cancer risk. And this question arose because we treat skin cancer risk in FGR 16 differently than we approached it in FGR 13. So the first question is, when reporting total radiogenic cancer incidents, should non-fatal skin cancers be excluded?
The question is very clear to me. Dr. Banke?
Agreed. Yeah, the question is absolutely clear, but what might help is, because the panelists are coming from slightly different backgrounds and directions, if the use of the risk coefficients can be explained so that everyone understands the implication here, it would be much easier to give sound advice. You see, what I'm getting at is that the panel is not going to say how to use the risk coefficients, but if EPA already understands multiple connections for these coefficients, if that can just be explained next month, I think it puts everyone on the right footing.
Absolutely. Thank you for that recommendation. And we can summarize the applications and use scenarios for these risk coefficients to provide that context.
Great. Lydia?
Thank you. I just wanted to just take a step further what Dr. Banke said, is that I'll be leading the writing for 2A. I haven't looked at the 300-page report in detail, but I hope that it contains a very good literature exploration explaining why you think it's important to change approach to skin cancer. And then we evaluate that, as opposed to us going out and doing the literature search and saying, well, this is what was done in this type of radiation in this report and so forth.
So thank you, Lydia. This raises another point. I wonder if EPA should, in the charge question, state clearly that the panel, it's out of the scope of panel's work to do our own literature review and so on. And EPA needs to do the job to explain basically what's been reviewed.
I have a question.
Dr. Stram, yes.
Yeah. So non-fatal skin cancers, is this primarily non-melanoma? I mean, what other fatal skin cancers are there? And any cancer could kill you, but that doesn't make it do you see what I'm saying? In other words, if you don't know until someone dies whether you have a fatal skin cancer or not. But if you have melanoma, that's a very high risk cancer that's customarily treated, as part of the risk assessment, whereas most of or virtually all the other skin cancers are considered to be essentially benign because they're so easily treated.
Dr. Stram, are you, I'm wondering, I'm trying to make sure that I understand your comment, and I think that to some extent I do. If instead of calling non-fatal skin cancers, should we just contrast everything against melanoma? Is that what you're saying?
Yes, that's my question.
Okay, so maybe Jonathan, we can look at this question to see clinically how precise the term non-fatal skin cancer means. is this a clinically accepted term? Maybe I have melanoma early stage. It's non-fatal, but I don't really know exactly how to word it, but I think it seems like Dr. Stram is implying that maybe anyone on the panel who has the clinical expertise comment on that.
I can add that we did not prepare to go in depth into this discussion for today, but we do intend to provide a little more context for the background of this question for the in-person meeting. I suppose for now the overarching question is whether the charge questions as written are unclear or whether we need to revise them. And I'm not quite certain what the change would be to the charge questions unless we're concerned about this the technical definition in this context of the non-fatal skin cancers versus non-melanoma skin cancers.
That would be my interpretation, but I'm not 100% sure. So I would like to see some expert input on that. I did talk to a melanoma expert in my school, and I also had that impression. So I guess a procedural question to Diana and to Jonathan and all the EPA colleagues. So we could finalize the charge question at our next meeting or before that, because we're gonna actually address the charge question by then when we meet in person.
Well, we should have the questions pretty much finalized after this meeting, because the panel have to start working on response to the charge questions. So if you have some undecided terms, we can discuss further. But I prefer to have everything finalized, after the discussion at this meeting.
Okay, so if the EPA had to go back to finalize it, is it okay that we have all finalized questions, charge question in about a week? Or maybe 2?
Well, I don't think that's what you want, because we already have a work assignment to all the panel members. So I don't think we want to wait so long to start working on the charge questions. So,
but I also have a sense that on the part of EPA, maybe it's hard to finalize the charge question on the spot. Am I misinterpreting the situation?
Well, they can have a few days maybe next week. Next week, to get back to me how to change it. I mean, I don't expect big changes. Maybe some wording to clarify.
Okay.
Yes,
Dr. Simon. Yeah, Dr. Simon.
Sorry, I for one would like to have some consultation with my colleagues before finalizing. So I'm not quite comfortable doing it on the spot, but we can certainly turn something around within a few days.
Okay,
that's good. That's good.
Okay, thank you, Dr. Simon.
Yeah, I wanted to ask. Question 1E is about risk models, and this question 2 is about skin cancer risk. I mean, why was this division between 1E and 2? Why isn't there a section? Why aren't the risk questions, more together? That's my first thing, and maybe it can be answered or maybe not. I don't know. But another point that I want to make is that if I was, as a physicist, if I was trying to assist a risk assessment of skin cancer risk, the question that's I think is important is never answered, and that is how you properly determine the skin cancer dose and what you actually mean, because the skin covers the entire body, and rarely, or not maybe not rarely, but not always, is all of the skin exposed. And this is widely not taken into account. How much of the skin is exposed? Where is it exposed? And what epidemiologic data do you have about partial skin exposure? There's a whole bunch of things in here that are not talked about and are almost never talked about because nobody knows the answer. But I think there's a lot more here about skin than questions are being raised about. And maybe some of my colleagues will want to comment on this as well. First part of the question is, why is 2 separated from 1E? Why aren't, and the second part was about the underlying signs for skin dosimetry and skin cancer risk. There was 2 parts.
Mm-hmm.
Okay, Dr. Simon, if you think there's some proposed wording to revising the question, let's be ready to discuss that. And then
Dr. Zhu, I don't have a solution. I'm just observing that 1E it seems awfully separated from 2.
Mm-hmm.
Okay, I'll let Jonathan respond to that. Then Dr. Behnke.
Yeah, the reason that the skin cancer risk question is separate is that we added it later as we were developing the charge question. So it's as simple as that. And additionally, when we were drafting the charge questions, what's not shown on the slide, but is part of the charge question memo, we do provide a little bit more context and background to the question itself. And just from a writing standpoint in developing that memo, it made more sense to isolate it out to provide that greater context. So that is why it's separated.
Okay.
If the panel feels that it should be integrated into the previous 1A, we can modify the formatting to incorporate it into the earlier charge questions.
Is there a strong or consensus opinion on that, or from
I was going to speak to it. Yeah, I really appreciate Jonathan's remarks, and more is going to come on this particular topic. I see question 2A as a strategic opportunity to address this point head on by the panel, and there are regulatory advantages of doing so, especially because this is a new part to the risk coefficients. So I would support 2A standing alone and having it be a very clear question in and of itself. I do have a remark. Thank you, Dr. Simon, for speaking up about several details related to skin dosimetry and risk. I think question 2D, Delta, is going to be the best place to provide recommendations there. Yes? Okay, wonderful.
Good.
Dr. Little?
Thank you, Roland.
Well, yeah, I to some extent go along with what Steve said. I mean, I'm puzzled by the separation of skin cancer here, and I'm wondering also why the emphasis on non-fatal. I mean, lots of cancers are non-fatal. Are we concerned with for example, other largely non-fatal cancers, for example, thyroid cancer in the same way? And also, just a point of clarification. I mean, skin cancer has been treated in some sets of risk assessments. For example, UNSCIR 2006 had skin cancer in. That was part of the it's based on lifespan study data. I mean, I know BA7 didn't, but there's no reason why it should be treated as something completely new.
Dr. Simon again.
Yeah. Based on Dr. Behnke's pointing out 2D to me, I would suggest to move 2D to be 2A. And I would say, are the underlying assumptions about skin cancer dosimetry And skin dosimetry and skin cancer risk models, are they adequate? Not are they adequately described, but are they adequate for their purpose? And I would move it to the first question, and then go into all these details, because if you can't get past the new 2A, you're going to have a lot of problem. If you can't say that the underlying assumptions are adequate for their purpose. And I think they do need some improvements from what I know. So that's the reason I would recommend moving it to be 2A and add the word skin dosimetry and skin cancer risk models. That'd be my proposal.
Yeah, I'm in strong agreement with that. Thank you. Yep, I think it's a great idea.
Okay, so the suggestion is moving D to A and describe other underlying assumption about skin dosimetry and skin cancer models and the data adequately described. Does that sound right?
Adequate for their purpose. No,
for their
adequate
purpose.
for their purpose.
Okay,
Because describing it
is
it's just a paper chase. Describing is just something you put on paper. Well, I want to know, are they adequate for the purpose, whatever that is, risk assessment of the average US American or whatever it is. Yeah. That's my recommendation, but others may feel differently.
So Jonathan, are we okay with this one? Okay.
I mean, are we so I'm not quite sure where we are in relation to the original 2A about non-fatal skin cancers. I mean, are we going to clarify this? That by this we actually mean a non-melanoma skin cancer.
We said we recommend to clarify that. But Dr. Little, if you want to propose, say, instead of saying non-fatal, let's say non-melanoma, and if EPA is
it might be best, yes.
Okay. But Jonathan, it's up to EPA to define this more accurate, but we are making a recommendation here. So 2A now become 2B, right? Okay, should we go through 2B now? And we have accidentally covered 2D already. So you want to go through 2B?
Yes, 2B was should basal cell carcinomas and squamous cell carcinomas be handled differently, i.e. from each other, with regard to inclusion in total radiogenic cancer incidence?
Could you say something about the risk differences between basal cell carcinomas and squamous cell carcinomas? Is it that one is a more dangerous tumor than the other? Is that?
My understanding is that the lethality of the cancers differs. And I'll invite any of my EPA colleagues who are well-versed in this to chime in if I'm misspeaking.
John, this is Armin, and I apologize that somehow in my Zoom I can't raise my hand. So can you hear me okay?
Yes.
Yeah, that's true. The basal cell carcinomas, almost nearly all of them are treatable, very easily treatable. A lot of times out of office, many people get them, in fact, multiple of them. And there are rare instances if it's not treated, it goes untreated, it could possibly lead to a more serious condition. But basal cell carcinomas are almost always entirely treatable. And they're not always also recorded correctly. So if you go to the ICD codes and try to get incidence data, that's the other issue, that you may not have reliable data on the incidence of basal cell carcinomas. Squamous cell carcinomas are also usually most frequently don't lead to being serious cancers, but they are more serious than basal cell carcinomas. And what's done in other publications is that because of the issue, because they give various reasons, ones that are basically very treatable, so morbidity of these cancers is not comparable to morbidity of lung cancer or other more serious types of cancer. That's one reason that they excluded. Another reason is unreliability of the incidence data because they're not always recorded. And so when we were looking at this, we have the data, but we didn't know whether to include that data, the cancer incidence data, or not. But in other words, given as far as if you look at the number of induced cancers, they don't have equal weight. And that's why a lot of times they're excluded. Going back to what Dr. Benke said earlier, the consequence of including skin cancers in the total incidence, it could have consequences because now you increase your number of total cancer incidents. But a lot of these, at least from the skin cancer, are treatable. So we wanted expert feedback on that. Typically, the practice is that if that are in total cancer incidence, they're excluded. Our feeling was that, well, we are saying total cancer incidence, and if we exclude them, we have to be very clear in our documentation that, look, we're excluding those. And if we include them, then we could justify it either way. But we wanted to hear your opinions on that, of what your recommendations are of how we should do this. That was the reason we asked the question.
The reportability problem is equally affects basal cell carcinomas and squamous cell carcinomas. Just to clarify.
It's mostly basal cell carcinomas, the reportability problem. Yeah.
Okay.
And typically, and also is very, for example, in Caucasian populations, that's very predominant. Of course, UV exposure is the main reason we get basal cell carcinomas. And with Caucasians have, I think, almost a twofold increased more sensitivity than others when it comes to the baseline. And with radiation induced is 5 times more sensitive. And also, the incidence of these basal cell carcinomas really is at high radiation doses. So it's a lot of issues that makes it kind of a separate issue in and of itself. But I've heard like people may have 10, 15 occurrences of these. One person may have 10 or 15 different occurrences of basal cell carcinomas in their lifetime. And could be that none of them even get recorded. Some of the cancer registries don't record that either. I think the British Cancer Registry, they do record basal cell carcinomas, and they give you a sort of a disclosure that don't trust these numbers too much. And for us, the SEER data, they don't even report basal cell carcinoma. So we'd have to rely on other literature, not our own National Cancer Registry. And we can talk a little bit about that more in May, maybe provide a little more context to the question if you like.
Thank you, Armin.
All right, so Dr. Little.
The only other aspect in which basal and squamous cell carcinomas differ is in the radiogenicity. There is, I think, quite a lot of evidence that basal cell carcinomas are radiogenic. Squamous cell, it's much less clear. There's some animal data suggesting that they may be, but not much human data as I know of. So that would be another reason for handling them differently. But anyway, that's something that should be considered.
Thank you. So my interpretation is that we don't really need to make any recommendation to revise or change the question. The question is okay. Thank you for the rationale behind this question.
Yeah.
Okay. Should we move to 2C? A, B, C are actually closely related.
Yes, and C asks whether there's merit to providing the total incidence values both ways, with and without non-melanoma skin cancers.
Any comments on any clarification question on this charge question to C? Dr. Benke?
Okay, so the only clarifying question would be, is there a distinction that EPA was looking for between the original 2A and the original 2C? Is there something special about the wording in C? I could speculate one thing, but I'd rather hear from EPA.
I think the question 2C was intended to ask whether it would be valuable for a user of these risk coefficients to have two sets of numbers that include and don't include the non-melanoma skin cancers.
Okay, thank you. Yeah, that was clear. Appreciate it.
Okay.
And John, may I add this? That question 2A, the original 2A, really should have said non-melanoma.
Okay.
Yeah.
Okay.
That will, resolve the inconsistency and the ambiguity. So thank you very much. So, So it looks like we're at the end of the chart question 2A. So we already state our recommended a modification for 2A. Well, so let me recap this. D will be A now. And then for the original 2A, we would use non-melanoma versus non-fatal. And otherwise, I think the question themselves seem to be clear. We didn't have wording for all the underlying assumption about skin cancer dosimetry and skin cancer models, and the data adequately described for their purposes.
Yes.
Okay. All right. Excellent job. Let's move on to 3.
Question 3 focuses on limitations and appropriate use scenarios. 3A is, are appropriate use scenarios for these risk coefficients adequately discussed?
I think the doctor, I forgot who mentioned this, use scenario. So this is discussed here, the charge question. Dr. Simon, I think it's Dr. Simon.
Yes.
I also asked a question about scenarios.
Right.
More related to how they were derived rather than how they were applied.
Right. Okay, Dr. Simon, then Dr. Dan Strom.
I find it odd to combine limitations and appropriate use scenarios. Those to me are very different things. But anyway, I think the main question that I would want to ask a review committee isn't listed here. It's not one of these. And that is, what are the implications for the user given the limitations and uncertainties? What are the implications? And I think that should be a question. And I'm sure Dan Strom and maybe Bruce or someone else will have some comments about that as well.
Okay, let's think about a recommendation in wording. Dr. Strong? Anyone else in the meantime? Oh, Dr. Strom back. Dan?
I apologize for my terrible service here. I keep getting bumped off.
It happens to me all the time.
As the lead writer for 3B, I've already expressed my views about uncertainty, and I would surely like to see uncertainty on these coefficients. that could be propagated into any use of the coefficients. That would be numerical uncertainties. And the categorical groups, you know, A through E, that were used in Powell et al. 2007, excuse me, those cannot be propagated beyond this. So I find that the sources of uncertainty are probably pretty well known, but the use of these coefficients is severely limited by the fact that that uncertainty can't be propagated. So that's my kind of repeating what I said on equation
right.
1B rather.
Well, thank you, Dan. Dr. Simon, maybe are you proposing adding a 3C that essentially says, given the uncertainty and the way the uncertainty was presented, what's the implication for application scenario? That's something
that's pretty
that
correct. Yeah,
okay.
I am proposing that.
Okay.
I am, yes. But I want to throw a question to my friend Dan, just for Dan to think about, and for me to think about, and Mark Little and other people to think about. If EPA says, look, these are the best that we can do, these ranges, these wide ranges, that may be a range of 100, what would you want to tell them if they say that's the best that we can do given the state of knowledge? I'm not asking for the answer now. I'm just asking for us as reviewers to think about it and be prepared, because we're really trying to help the EPA. I mean, they have a really hard job, right? We all acknowledge that, and they've done it, and they usually do, and they are doing a terrific job in my mind, even though I haven't really studied the report, because it's a huge undertaking. So we have to be helpful. And one of the things is when you, what are we going to propose to them to do it better? Anyway, Dan, you and I can think about that.
Would you mind just taking a second to define use scenario?
Yeah, that's a good question.
For the appropriate use scenarios, we try to convey to the reader that these are intended for population level estimates of radiogenic cancer risk and are not intended for specific individuals. And so we outline in, I believe, the first chapter, situations in which it is appropriate and not appropriate to use these risk coefficients for risk estimates. So that's what we intended here with appropriate use scenarios.
Okay, that clarifies it a little bit. Thank you.
Does the report provide any examples of use scenarios?
We provide some example calculations where one might apply these risk coefficients as an appendix. And funnily enough, that is one of the sub-questions under question 4 that we'll get to in a moment.
Okay. So any further comments on question number 3? So if I could recap what we have discussed and what we have proposed, we proposed to EPA to add 3C that roughly reads, given the uncertainties and the way they are quantified, what are the implications of their applications / or user scenario? Does that capture what Dr. Simon and Dr. Strom suggest? Okay. Then you have someone taking notes, or you want me to send you, along with Diana, send you something in writing?
Yeah, well, I certainly like to see
Jonathan, I'm sorry. No, I mean,
I have been taking notes.
Okay, great.
As we go along.
Okay,
thank you.
All right. Sure. So I think we're doing great. Let's move into question number 4.
Question 4 looks at the report holistically and focusing on the clarity. So first part of question 4A, is FGR 16 comprehensible? Is it accessible and appropriately written for the intended audience? Are there any issues with the writing, organization, formatting, navigability, etc. of the report and the tables?
Sounds like question 4 are easy, easy treat, right? Any comments on 4A? Whether the question is unclear or you want to make it more comprehensive?
Is the audience, without having completely read the report, is the audience, the intended audience, is that rigorously defined? Because if it includes professionals and includes the public, that's really that's a huge, widely dispersed audience in terms of whether the report is comprehensible. Anyone that's done risk communication knows that it's really a big, difficult problem. So I'm just asking, is the intended audience clearly defined in the report? Just for my own information.
Jonathan?
It is not explicitly defined in the report. The report does specify that the document is intended for individuals or organizations needing to conduct these risk assessments. I can say that this report was, because it is a technical report, does not it was not intended for a wide public audience in terms of its plain language and understandability. It is intended for a technical audience.
So can we clarify 4A by spell out what the intended audience is? So that we don't have to go back to the entire documentation to find out what your definition is. Just repeat it here.
Yes.
Okay.
We can clarify that in the charge question directly.
Excellent. All right. Looks like we are moving to 4B.
Yes, 4B is what I just alluded to. Are the examples in Appendix A adequate to demonstrate the use of FGR 16 risk coefficients in a range of applications?
I think that's pretty clear.
Okay. But how many examples do you have in Appendix A? I apologize that I have not read Appendix A yet.
I believe we have 4 pages worth, and the exact number of examples I think is 4 or 5, but I will need to verify that.
Okay. But that's in a very sort of, to me, there's a very ambitious expectation on this question. If you only have 4 or 5 examples, you have thousands of radionuclides to say it's adequately demonstrate the use of all these coefficients. That's going to be hard to judge.
We'll take a look at that and see if we want to reframe it to be a little less expansive.
Yeah, maybe specific on the key radionuclides. Maybe that would be more specific. Any other comments from the panel members? Okay, so there's a comments in the chat box about 5 examples. The appendix is only 2 pages. Okay, so the recommendation is EPA consider to make this question more specific with its scope.
Yes.
Because to cover all these thousands of radionuclides, it's going to be very demanding. Without any further comments, should we move to charge question 4C?
Yes, 4C is when discussing risk estimates for occurrence of disease, are the terms morbidity and incidence appropriately used in the report?
I'm in charge of that one. I'm kind of curious why that arose. I mean, those 2 terms are often used interchangeably, so I'm just sort of curious about that.
in fact, they are used interchangeably in instances throughout the report, and this was a discussion we had among ourselves, and with arguments on both sides for them being used interchangeably or using one or the other. And we thought it was a question we could put to the SAB review panel to get some input on. And Armin, I saw your hand go up momentarily if you would like to
add. Sure. Yeah, they are used many times interchangeably. And I've been sort of talking with John Boyce and Richard Wakeford on this, getting their input. The incidence, of course, it is what it is. It's incidence of cancer counts. Morbidity is sort of a broader term because it does take into account the quality of life for the patient, the severity of the treatment, and it has some attributes that are not easily quantifiable. So even though morbidity and incidence, they're used interchangeably and it means that way, but in truest sense, they're not identical terms. And so we wanted to get your feedback on, in fact, when we looked at it, in FCR 16, we hadn't even used it consistently in that document. So we thought to get your feedback and input on that and what you thought, how we should do it.
Thank you. Dr. Strong?
Thank you. I'm brought back to the discussions in ICRP publication 60 about lost life expectancy, number of years of life lost for a particular kind of cancer. And I think leukemia was 30 years and bladder cancer was 9 years. This is ICRP 60. And they had this formula where they figure the more life you lost, the worse the treatment, that is, the more serious the morbidity was, to use Armin Ansari's term. So I'm wondering about, are those expressions years of lost life expectancy? Is that just too simplistic? I mean, the thing that ICRP did in report 60, publication 60. I guess, well, I haven't seen anything like that in my perusal of the report.
I don't believe we addressed lost life expectancy directly in the report.
And I think Dr. Collins was speaking, but I saw his mouth moving, but he was on mute.
I just wanted to say that loss of life expectancy is a function of mortality and not morbidity.
Yes, but in ICRP 60, the more life expectancy you lost, the greater the morbidity. That was just their approximation. I'm not saying it's valid, but that's what they said. So it is determined by mortality, of course, you're correct. But if you lose a lot of life expectancy, that means a treatment would also be aggressive and that, not that successful. That was their implication.
Okay.
But I guess the question is clear, right? I mean, if we could take into consideration loss of quality of life in morbidity, then the incidence definitely doesn't tell us. I think I could appreciate the sophistication of EPA by raising this seemingly simple question.
This is Dan Strom again. If I could just mention that all of the reasoning about lost life expectancy came into ICRP's definition of detriment, which is expectation of harm in those days, at least for ICRP. And the expectation of harm was supposed to include morbidity and mortality. Mm-hmm. And the way they weighted morbidity was using that years of lost life expectancy. I thought it was very clever and innovative at the time.
Any suggested changes to this question? This is a great discussion.
It's clear to me.
Okay. Yeah, it's a clear. I agree. It's very clear. All right. Without that, I think we're almost done with the charge question. This is very, very efficient and effective discussion. So I guess the only recommended change is to make 4B more specific, more in terms of scope, demonstrate maybe key issue. That's just the suggestion.
Yes.
Okay. Any other comments before we move to the next agenda item?
I'm sorry. I thought there was Armin made a good point about 4C, which I think ought to be reflected in that.
Oh, just more explanation.
Well, the difference between morbidity and incidence. So so I don't know how maybe Armin could provide some words here, but I think that does need clarifying.
Okay. So if I could take this a step further, so we would like EPA to underline the rationale that in its own perspective, the difference between morbidity and incidence, especially the implication on the morbidity.
Yeah.
Right. Okay. Sorry, I forgot to mention follow this up. All right, Jonathan, you got that right?
Mm-hmm.
Okay. Dan, your hands is still up. Do you have another comment?
My comment is not on 4, but on 3. Is it true that when you're talking about use scenarios in 3B, it's table 1-1 in the document?
I believe so. Is that it's got the circles and the dots, and some of them are crossed through. Yes, that and the accompanying narrative in the report.
Thank you.
Right. So Dan, you got your clarification. It doesn't have to change the question, right? Or you want to EPA make a reference, say it's a table, blah blah blah.
Well, as long as we know what we're doing in May.
Okay.
That's fine.
All right. I think I'm ready to move to the next agenda item. That is, well, let me just give everybody 5-second pause, see if we have further comments. Well, hearing none, let's move to agenda item next steps. Okay, so actually, Diana is in a better position to explain to the entire panel what the next steps are. I mean, of course, we all know that we're gonna do the review, start our draft writing, and then we come to in-person meeting at the end of May and have a group discussion. So with that, I'll turn this to Diana.
Okay, thank you. Well, the next step, the first thing to do, obviously, is for EPA to finalize the charge question, revise the charge question, and send it back to me for web posting. So I see there are changes, but not a whole lot of changes. And if Jonathan needs some clarification, he can always email to me, and then myself and the panel chair, can help to clarify. But as I see right now, there are some changes, and there's addition of a subcharge question. In one case, I think it's in number 3, and then move around a question in charge question 2. Other than that, they are not big changes. But again, if Jonathan needs clarification, he can always email to me to make sure, we all agree that these are the changes to be made. So with that, I don't expect it will take a long time for EPA to finalize the charge questions. So would it be possible for EPA to send back the final charge question to me early next week, Jonathan?
Yes, I think that's doable.
Okay, that's great. Because after all this discussion, I'm sure the panel members can't wait to start working on the response, right? The assignment has already been made, and everyone is clear about the charge questions that they should be working on. So as a matter of fact, they can start working on it right after this meeting. And the expectation is that the panel members should prepare a preliminary individual response to the assigned charge question and send back to me about a week before our face-to-face meeting on May 29 to 31st. That means the due date for them to send their preliminary individual comments back to me will be May 22nd. That is a week before the scheduled meeting. So after I receive the preliminary comments, I will compile all the response together and produce a document. And then this document with all the preliminary individual comment will be posted on the meeting webpage. That is our next meeting webpage. And so that the public, EPA, and also the panel members can review the preliminary response. Now, this is important because if you are the lead discussant, as I explained, one of your responsibility is to summarize the individual comments from your team members. And during the face-to-face meeting, the panel chair will call on you, will call on the lead discussant and give a summary of the response from his team members. Okay, so it is important that everybody do the assignment and submit the response on time so that the panel members have some time to review the individual response and then do this test for the in-phase meeting. So for the format of the face-to-face meeting, I already explained that the panel chair will call on the lead discussant and give a summary, but then the individual team members will also have the opportunity to add to the response, or they may want to clarify something, so that the team members will also have the chance to provide the input at the face-to-face meeting too. And after that, the charge question will be open to the entire panel, so that panel members who are not on that team for that specific charge question will also have the opportunity to provide input. So that we'll just do this for every charge questions. Okay, so that is what the face-to-face meeting is about. So after the face-to-face meeting, the lead discussant will then become the lead author. That means that the lead author will now have to write up the written response to that specific charge question with the input from the individual team members, the written response from the individual team members. So the team members, they can communicate with each other while they're doing this test and via email, and they make sure that they have to CC me and also the panel chair, because that is part of the FACA requirement, because we have very strict record keeping requirement. So after the team reach concurrence, all the team members, of course, will have to review what the lead author, wrote, and then they all have to agree and concur into what is written down before the lead discussant or the lead author send the written response to me. So you must have concurrence before you send back the written response to me. I would then, yes?
Dana, can I jump in to make an comment?
Sure.
So my understanding is that we are aiming to develop a consensus-based report, but we definitely also allow minority opinion where you have your dissent. Can you explain to the panel members, just in case that some of us are less familiar with that?
Yeah, sure. When I get to that step,
Okay.
Because right now we are only on about our team response, okay?
Okay.
Not the entire report. Because
Okay.
the minority opinion, that will be when we're talking about the entire draft panel report. Because right now we are still in the early stage. So every team, the lead author will prepare a written response, and then within the team, they have to agree. If they cannot agree, then they may have to have some discussion, with me or the chair, individual, to try to reach agreement. That is just within the team. So usually there shouldn't be a problem, it's maybe just a matter of changing the language or something like that. Okay, so when I receive all the written response to individual charge question, I will be the one who put together the report. I see a hand, Mark Little.
Yeah, sorry, I'm not quite clear as to the timing. So Diana, are you saying that you want a consensus
Within the team.
within the team delivered
Right.
to you by the 22nd of May?
No. As I say, the 22nd of May is only for individual preliminary comments. The team is not involved.
No, but sorry, by the team, I meant the particular group of people responsible for each charge question. I mean,
right. They each write a preliminary individual response.
Yes,
So you will read it over. You will read over their response. Hopefully they all send me the comments, the individual comments by May 22nd, and I can compile them so that the lead discussant will have some time to review and summarize them at the meeting.
Oh, I see. So you're saying that actually we just all send our comments in individually to you.
Right.
Okay, right. And then somehow,
and then you will discuss. The team will, the entire panel will discuss. So
should we not deliberately not copy our comments to the other team members?
No, I don't think you should, because you don't have time anyway. You don't really have time to discuss with others. You will discuss at the meeting.
Okay, fine, right. Okay.
So is that clear now?
Yes, that is, yes.
Okay, because you don't really have time to discuss with the team member. You will do the discussion at the meeting.
Then develop the report. Diana, I think Gail has her hand up.
Yes, Gail. Gail?
Related to that, do we prepare comments for every single question that we're involved in?
You are assigned to, because I sent out the charge question assignment table, because I realized that you don't have time to write up so many responses to every single charge question. And no, it is advisable, because you should only respond to the questions that is your expertise, involved in the area of expertise. So nobody will answer every single questions.
And the questions have now changed. I think it's only 2 that has changed, right?
We had an additional question for 2.
Oh, I see. Yeah, so the charge question assignment will be finalized after we have the
Thank you.
The question is finalized, but that will be very minor. Just add one question. So that's fine.
Okay, thank you.
So any more questions?
Yeah, could you clarify again how long after the in-person meeting the consensus report from each team leader needs to be provided?
Well, usually I give the lead author about 6 weeks to prepare the written response. So you have plenty of time, because you already prepared the preliminary before the meeting. And after the meeting, usually I give them 6 weeks or so to prepare the written response from the team. from the team, not just yourself
Okay.
now.
Okay, I have a second question. Thank you, Dan. I have a second question. When you post the individual panel members' responses for the public, are those responses identified by name?
Yes, yes. So say you are Dr. Steve Simon, so that, all your written comments will be under Dr. Steve Simon. Yes, by name.
Okay.
Dr. Strom, hands up.
Yes, Dr. Strom?
Diana, I would really appreciate seeing what you just told us in writing, a sequence of deliverables, who does it, and when.
Yes, yes. I will send you email too. Because right now I'm just trying to answer your questions, so you have some idea what you're supposed to be doing. But I certainly will send out email. And of course, I have to send out the finalized charge questions too when we got it next week. Okay, any questions before I continue with the process? I didn't finish with the process yet. Okay, so I was talking about, I will put together the draft panel report. So the draft panel report would then be posted on our webpage, and then it will be undergoing public comment. Okay, and also EPA can also review and they can also comment. And of course, the panel members can now review the entire report and also comment on it too. Okay, so usually we allow about 30 days for the public to comment before we have a follow-up meeting for the panel to deliberate on the draft report. And I will schedule the follow-up meeting. And of course, for the follow-up meeting, and then there will be changes made because of the comments that we receive. So the report has to be revised, okay? And then this time we will have to get concurrence from the entire panel, okay? And so this is where the question from the panel chair comes in, because we are providing an advisory document to EPA. So we are trying to, usually we have consensus within the entire panel. But in some cases, there may be some minority opinion on certain issue that this person really cannot agree after a lot of discussion and everything. Then these panel members, they can write minority opinion, usually at the end of the report as an appendix. Okay, so this is where the chair's question come in about the minority opinion. And with that, so when we have the report revised, then we will send to the charter SAB for quality review, because the advice given to the EPA administrator is not from the panel, but is through the charter SAB. So that's why the panel report has to go to the charter SAB for quality review. And the panel chair will have to present the panel report and answer questions from the charter SAB. The quality review meeting by the charter SAB will also be a public meeting. Okay, so at the meeting, the charter SAB member then will vote, on the disposition of the panel report. There are three options. Option one is the best option. The panel report will only require minimum changes, mostly editorial changes, and then will be reviewed and approved by the panel chair and also the charter SAB chair. And so that is the best option. And option two will require more work and will be revised by maybe some certain members of the panel. And the revised report would then be reviewed by select SAB members and has to be reviewed and approved by the charter SAB chair and also by the panel chair. So that is option two. And option 3 is the worst option, and that is the report is sent back to the panel to rework, need more work. So I'm sure, we have a very good panel members, so we will try to get the best option. So the timeline, usually from the start of the SAB review to submission of the final report to an administrator, is usually about 9 months for completion. So that is the SAB review process. So is there any question? No question? Everything is clear now. Oh, okay, that's good. So if there is no question, yes. So everybody is happy and ready to work, right? Okay, so with that, I would like to thank the panel members and also the public for participating this public meeting. I would also like to thank EPA presenters and also presenter from Oak Ridge, present the outline of the overview of FGL 16 and also answering so many questions. And last but not least, I would like to thank our panel chair, Dr. Xu, for his leadership, giving guidance and leading us through this meeting. So I would like to remind everybody that the follow-up meeting, our face-to-face meeting, is going to be May 29 to 31st, and it's going to be at Doubletree Hotel in Arlington, Virginia. The exact address is given on the meeting webpage. So you intend to go to the meeting, you should look up the address there and attend the meeting. And for the public who wish to give public comments, they should send me an email no later than a week before the meeting. So is there any other questions?
Diana, I do have one question and a comment, and let me say the comment first. I want to second your vote of saying thank you to everybody, to our EPA colleagues, to the public for participating this meeting, and I also want to thank all the panel members for a very productive, effective virtual meeting, and I look forward to meeting everyone in person in a month. But a lot of hard work ahead in between. Okay, thank you very much, and I want to also thank Diana for coordinating, facilitating this meeting. Without her, it's not going to be easy. And then I do have a comment that is, Diana, maybe you could clarify the way the communication can be conducted among the panel members. Maybe you can spell out the federal government regulation. So I think discussion among panel members definitely would be helpful and help to achieve consensus. And we also learn from each other. This is truly a team science, right? But there's some regulations, in terms of, for example, with academic science, they also encourage you using private email account rather than university at the risk of being subpoenaed or whatever, right? Do you have any advice for people?
Yes, I can answer to that. I can answer to that. Because this is a FACA advisory committee. Okay, so when there is deliberation, it has to take place in the public. So that's why when I assign charge question, every charge question cannot have more than half of the panel members involved. So within the team, you can exchange email, but has to be less than half of the panel. So that's why there's a limit to the number of discussion for every charge questions. Okay, so please don't send email to the panel members outside your charge question, because if you do that, you send out email to the entire panel, that will become a deliberation. And under FACA, deliberation has to take place in public. So that is the FACA rule that you have to observe. Okay. So as for the other question you may have, I will schedule administrative meeting. Okay, so that will give you more detailed guidance about what you can do or what you may not be able to do. But that will be more administrative. So I don't really want to talk about it now in the public meeting.
Yeah, well, thank you so much, Dana. I mean, giving panel member sort of advice as to what are public records, what are private conversation that would help facilitate that process.
Okay, so any more questions? Okay, with no more questions, though, thank you again to everyone. And this concludes the SAB Radionuclide Cancer Risk Coefficient Review meeting. Thank you and see you in a month.
Well, thank you, everyone.
Thank you.
Take
Okay,
care.
bye.